Hello, Algebra 1 students. This is Mrs. Raposa, and this is your lesson on Section 4.6, Modeling Direct Variation. So you should have a copy of these blank notes already. If you don't, hopefully you can print a copy. If you can't print a copy, then maybe you can take notes on a piece of graph paper. Let's start by describing what a direct variation equation is and what the constant of variation is. A direct variation equation is any equation that looks like this: y equals some number a times x. So the only number that a cannot equal is 0. So a should not ever equal 0, because then we just have y equals 0 times x, so that would just be y equals 0. And that's not direct variation. The constant of variation is just that number a that's being multiplied by x. Now, if you think of a linear equation, linear equations are always any equation that take the form y equals mx plus b, right? I'm going to just pull this down here. So y equals mx plus b is a linear equation where m is the slope and b is the y-intercept. Well, this is just the same thing. We just have y equals a times x plus 0. Because a is just taking the place of the slope m in this equation. And in this case, b will always be 0. So we don't even really need to add the plus 0. We can just get rid of it and just put y equals ax. If you want to put plus 0 there, you can, but it's the same thing. So in this case, b is going to be 0 for every direct variation equation. Okay, so before we go on any further, I think it's a good idea that you make sure you have all of this information written down at the top of your notes. So let's go ahead and do example 1. So for example 1, we have to tell whether this equation represents direct variation. And I can see right away that it's not in the form y equals some number times x. But maybe when I solve for y, I will see that it is some number times x. So what we have to do here is we have to solve for y, or get y by itself. So that's the first thing you want to do. So in order to solve for y in this equation, I'm first going to have to, this is the variable I need to get by itself, y. So the first thing I'm going to do is I'm going to subtract 4x from each side. And subtracting 4x from each side will leave me with this equation. This will cancel. 4x minus 4x is nothing. And I'm left with negative 5y is equal to 0 minus 4x, or negative 4x plus 0, which is what I'm going to write. And you know what? I don't even need to write negative 4x plus 0. I can just leave it as negative 4x, because if I add 0, it's just negative 4x. Adding 0 doesn't change it. The next thing I need to do to each side of the equation is divide by negative 5. So I'll go ahead and do that. And I can see that what I'm going to be left with is this equation. Y equals, on this side, I have my fraction that's being multiplied by x is a negative 4 over a negative 5, which is going to be 4 over 5 positive, because a negative over negative is always going to be positive. So I have y equals 4/5 times x. And this is in the form y equals some number times x, where that number a is not 0. So this is direct variation right here. So yes, it is direct variation equation. And it says here to finish the question, if it is, identify the constant of variation. Well, the constant of variation here is my number a that's being multiplied by x, so that is 4/5. So let's go ahead and graph the equation too. So there's 3 parts of this. Tell whether it represents direct variation, so yes it does. If it does, identify the constant of variation, I have that there, and graph the equation. So let's do the third part. To graph this equation, I'm going to have to put a point at the y-intercept, which is going to be 0. Every direct variation equation will have a y-intercept of 0. And the slope is 4 over 5. So 4 is my rise. I'm going to come up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So there's another point on the graph. I could also go down 4, 1, 2, 3, 4, and back 5, 1, 2, 3, 4, 5, and get another point. So my line is going to be right here. There we go. Beautiful. And so there's the graph of y equals 4/5 x. Looks like I missed that point just a little bit. It's kind of hard to do on the computer, but there it is. Okay, so let's go to example 2. Let's determine whether this equation represents direct variation. Remember that in order to do that, I'm going to need to get this variable y alone on one side of the equation. So the first thing I'm going to do to each side is I am going to add x to each side of the equation. Add x to this side. Let me pull that down a little bit. And I'm also going to add x to this side of the equation as well. It might be helpful if I put in the line down the center of the equal sign. Whatever I do to one side, I have to do to the other. If I add x to both sides, this cancels. And I am left with y equals 1 plus x, or I can just call it x plus 1. And I can stop right there, and I can see that this is not direct variation because this is a line with a slope of 1 and a y-intercept of 1. So the problem here is that the b value does not equal 0. And so no, this is not direct variation, because if it was direct variation, I would just have y equals a times x and the y-intercept b would be 0. But it's not. This is y equals 1x plus 1. Okay, what I've done here is I've graphed the equation y equals x plus 1, where the y equals m is 1, which is 1 over 1. That's my slope. And b is 1, so I started by plotting the b, the y-intercept, where y equals 1, and then from there going up 1 over 1, because my slope is 1, up 1 over 1 again, and there's the line, and you can see that line does not go through the point 0, 0, where the two axes intersect. We call that the origin. This does not go through that point, so this is not direct variation. Okay, let's go to example 3 now on the back side. And we're told that this graph is a graph of direct variation. And we need to write the direct variation equation. And we need to find the value of y when x is 14. So the first thing I'm going to do is I know I have to write some equation for part A of this question. I know I have to write y equals some number a times x. And that a is really just the slope. So I'll put that over here, that a is just the slope. So I need to find the slope of the equation. And I can tell it's direct variation because it does go through the point where the x and y axis meets. So it goes through the origin. So from here, I'm going to find another point that's right on the grid intersections, like not here, but like right there where the grid intersections are. So from there, from 0, 0 to that point, I can say I go up 1, 2, 3 points. So I go up 3 and I go over 1. So it looks like my rise is 3 and my run is 1 from that point to there. So it looks like my slope A is going to be 3 over 1. So that's my constant of variation, 3 over 1, but I'm going to simplify that and just call it 3. So that's my A value. A equals 3. And so to write the equation, I write y equals 3 times x because A is 3 in this case. And that is the answer to part A. Now let's do part B to this question. Part B asks me to find the value of y right here when x is equal to 14. So I'm just going to write y equals 3 times 14 because we're going to replace the x with 14. And when you do 3 times 14, you'll send to the calculator, you get that it's 42. So that is the answer to part B. When x is 14, y is going to be 42. For example 4, we're told that y varies directly with x. So this y varies directly with this x, and use the specified values of y and x to write a direct variation equation. So a direct variation equation, remember that looks like this: y equals some number a times x. We have to figure out what a is. That's what you have to do here, solve for a. And we have the x and y values to plug in for x and y to solve for a. So I replace this y with negative 16. That's what I've done here. And I replace this x with 12. That's what I've done here. So the equation becomes negative 16 equals some number a times 12 because y equals some number a times x. So I just solved this equation, and the only thing I need to do to each side of this equation is divide by 12, and dividing by 12 on each side will give me, this will cancel. I'll have a is negative 16 over 12, and I can reduce that. 16 over 12, both 16 and 12 are divisible by 4. So I'm going to divide them both by 4, and I have a negative divided by a positive, so I know that my value of a will be negative. Divide 16 by 4 and I get 4. Divide 12 by 4 and I get 3. So my value of a is negative 4/3. So my equation then becomes y equals negative 4 over 3 times x, because a is negative 4/3. Now what they didn't ask me to do here was find y when x is some other number. And you will have to do that in your homework. So I'm going to put over here, if x equals, like, we say x equals 2. Let's find the value of y. So all I need to do is use this equation. So when x equals 2, I'll have y equals negative 4/3, which is kind of hard to write. I'm going to just write it as a fraction. So negative 4/3 times x, which we know will be 2. Oops. And negative 4/3 times 2, I'm going to write that over here. That's going to be negative 4/3 times 2 over 1, because 2 is 2 over 1. The reason I want to write it as a fraction is because I'm multiplying fractions. And to multiply fractions, I'll just have negative 4 times 2, which is 8. And I'm going to make this fraction negative 8. And over 3 times 1, which is 3. So when x equals 2, y will equal negative 8/3. Okay. Okay, last thing that I'm going to have you write in these notes is going to be on the back side, and I want you to just write this definition that two variables, x and y, show direct variation if y is equal to a times x and a does not equal 0. This is actually the answer to one of your homework questions from pages 256 to 259. When you do this homework assignment, please make sure that you have these notes in front of you, because the problems that you're asked to do are exactly like these examples. And we'll leave with a joke. What did the 0 say to the 8? Maybe you've seen this joke before, but if you don't, let's get rid of it, if you can guess. He said, nice belt. Okay, we'll end on that note. Have a great day, guys.